Hello everyone, I'm Abdul and today the purpose of this tutorial is to tell you about the basics of digital signal and processing. And so, as we know that DSP stands for digital signal and processing. So first of all, let's say what is DSP. So basically, DSP is finite or discrete set of values to represent real world objects. For example, binary systems. So, and we have the signal, and signal is physical quantity that changes with respect to some independent variables such as time and space. So signal is basically anything that gives you an information. So then we have processing. So what is processing? Transformation via algorithm or technique that converts a signal from one form to the modified version of the original signal to achieve desirable objective. So in basic language we can say that processing is something when we process something we want something, and through processing we achieve the required objective. And so when we combine them, DSP creates DSP, and DSP is that it is a technique, it is mathematics algorithm and technique used to manipulate signal after they have been converted into digital form. So for example, we can use DSP for enhancement of visual images, speech recognition and generation, compression of data for storing and transmission. And we have the two domains that is frequency domain and the time domain. And let's consider an example for DSP. For example, let's say we want to we want to send these three images through a transmission line from source to destination, and the pixels of for example we have the image one. It's they all have the same resolution, and they all have the same pixels. So let's say that we have to send these pictures as it is and calculate the time. So when we send them, since the channel bandwidth is 1 kb per second, so here we can see that the time is 120 plus 120 plus 120 is equal to 360 seconds. It's a lot of time. So let's use another technique. uh, let's see that where we can send these images by finding chains, so we can reduce pixels and time. Since in first image we have a house, and in second image we have also have a house, but there is a man's stick figure standing. So that's the change. We are going to calculate the resolution of only the change, and here only the change. And then so there is so then the pixels become less. We have the image A pixels 120K, and the image B pixels for only man is 15K, and similarly for image C is 15K. So when we find the time, that's 150 seconds, which is which is less than 360 seconds. So we just used a technique, basic technique. Then let's say then we have another method by compression. We use compression to compress the data, so that we can send it through any transmission line, etc. So here we're doing the same. We are compressing the image. We are compressing the image over here. Then the new pixels are 1.2K, 0.15K, and 0.15K for the image. So here the time is 1.5 second. So we just used a basic DSP technique uh, to have to get less time and pixels. And then another example we are going to discuss is of sorting. So let's suppose we have a data, unsorted data over here. These are random numbers, okay, unsorted data kind of. And for instance, we just want to search 45 from this unsorted data. So any kind of system would go through iterations to search this number. Let's say we want to search 45, so the system will go from this. It's not 45, then it's going to jump from to the next number, and it's not 45, then it's repeat itself, and it will repeat itself until it finds the number. So uh, uh, in case of 45, we have 9 iterations from 1 2 3 4 5 6 7 8 9. So 9 iterations, and let's suppose we have to search for the iteration, the number of iteration in it are 5, and let's suppose we have to search 65, which is, you can see, not present in this unsorted data. So here this is the worst case. It won't detect, it won't the system won't detect instantly that there is no 65 number in this unsorted data, but it will go through all the iterations, and then it will say no, there is no 65. So this is the possible worst case. And the worst case, so in this type of unsorted data, it's also known as linear search. In this, so for linear unsorted data, worst case is n means the number of data we have, the number of values we have. So, and the best case for this for this example is that the number we are searching is the first place. So it's a very, since it's a very tiring method, so why don't we use a DSP technique to, uh, so that we can find easily, we don't have to go through all the iterations. We So there's a method that's known as binary search. Here, let's suppose it's a method, okay, and it's predefined, it's a method, and we're going to discuss this. That in binary search, let's take the same case. Remember, in when we searched 45 in unsorted data in linear search, we go through the nine iterations. But let's suppose we are searching the same number 45, but this time we are using a different technique, that is binary search. So the method consists of the following steps. First, you need to find the mid number of the unsorted of the sorted data. Let's suppose we have the sorted data over here, and we need to find the mid number. So here you can say the mid number is 21. So, and then we will apply a condition whether the number we want to search is less than the mid number or greater than the mid number. It's clear that 45 is greater than the 21. So why we're checking it, I will show you. But let's see here. Let's suppose, and this is the mid number, and there are two blocks created, so this is the mid number. So since 45 is greater than 21, we're going to select this block, okay. So when you have selected the block, again we're going to find the mid of this second block, that is this, okay. Now we're going to apply the same condition. If 45 is less than 52 or greater than 52, it's obviously it's obviously less than 52, so we're going to select this block. So now we're going to apply the same condition. We're going to search the mid. This is the mid. Then we can again search the block, and then we're going to find the 45 number. So how many iterations? 1 2 3 and 4. So we completed this search in just 4 iterations, where in unsorted data in linear search we completed the search in 9 iterations. So this is a big advantage of DSP. We can use DSP in digital signal processing to for our own advantage, and to minimize the usage of time, energy, and everything. So that was the most basic lecture on the DSP. Thank you.